Hello College Algebra student, this video is for chapter 6.6 part 3, solve log equation. So we finished two parts of the videos on solving exponential equation where the unknown is in the exponent. Now our unknown is trapped inside a log. So it could be like 2x plus 1, whatever that is inside a log with a certain base. So warning and before we go into how to solve it is, if you have a log of something, x plus something, you're going to see you cannot subtract the b outside. You cannot just say minus b like this. When something is with a when you have like add and subtract in a log, you cannot move it inside or outside. You cannot combine it. So cannot use combined like term to move things inside or outside. Cannot divide, like if this is 2x, you cannot divide it by 3. So that's the first things that you need to know. Do not think that, oh, I can just do that and then cancel the log or whatever. No. The second thing you need to know is we know that log has a restricted domain, right? Anything inside the log has to be positive. So after you solve your log equation, always check against the domain. And before you solve any log equation, you should notice what the domain, the implicit domain is supposed to be. And again, what is the approaches? The approaches is if you have log, one log equal to a number, then you use definition of log to rewrite it into exponent to solve. So in this case, it would be b to the power c equal to s. So anything that is inside the log, like your x is here, your unknown is here, is free. It's now is free up from logging in, like trapped inside this log function. So it becomes something that you can work on. So that's one way. The other way is if you have log on both sides, of course they have to be the same base. Then you can just say you use something called a one-to-one properties. Log is a one-to-one function, so you can just do s equal to t. So you can actually cancel it. So actually the theory behind this is you would just apply exponent b on both sides, and then b to the log is inverse function, so they would cancel each other. So you have s and t, right? So behind the theory, it is because you apply an exponent. But in the sense, what you do is if you see two log on both two sides, you cancel them. Okay, but this is only applicable if you have one log on one side, one log on the other. If there are multiple terms of log on both sides, you use log probably to combine them into a 1 on one side and 1 on the other side before you do the cancel. The fourth things after you solve the equation is always track for extraneous solution. So do example. So we have log base 9x equal to 16. So earlier we say you cannot move things in and out inside the log, but outside you can clean up, right? So inside there is only x, but there is a 8 outside, so you would divide it first until you have one log of base 9, and then the unknown inside equal to 2. So you have one log equal to the number. What should we do? We would say, okay, so I would rewrite it as exponent notation. Remember in 6.2 we do a rewriting. Is it 6.2? 6.3. It will be base to the power equal to x. Right, so x is equal to 81. So the second one is we have the x is all trapped inside this ln function, right? All these are not inside, so I can, do the subtraction just like when we are solving things, but anything here inside this 3 you cannot subtract. So it's still intact inside. The only way is if you can, cancel the log by rewriting or anything. So this is 3. Now I need to divide it by 2. So these are anything that is outside I can do. 3 plus 2x equal to 3 over 2. 3 over 2. Now I will go look at one log, one number. So I will say I'm going to rewrite. Okay, so if it is one log, one number, it is rewrite. Rewriting time. So what basis are we talking about? Is e to the 3 over 2 is equal to 3 plus 2x. Now there's no more log. Everything is free. And e to the 3 over 2 is actually a number, so it's a constant. So what you do is your x is just 2x, so you clean up the 3 now, minus 3. So e to the 3 over 2 minus 3 equal to 2x, and then you divide it by 2, divided by 2. So x is equal to e 3 over 2 minus 2 over 2, minus 3 over 2. So put in the calculator. I didn't do this ahead of time. E to the 3 divided by 2, and then minus 3. Press enter first because you have to do that first, and then the whole thing divided by 2. So it turns out to be 0.7408. Now, in this particular case, I have to make sure that this is in the domain, right? So what is the domain of this expression? Is the inside has to be positive. 3 plus 2x has to be positive. That means 2x has to be greater than negative 3 because I will minus 3, minus 3. X has to be greater than negative 3 over 2. This obviously is greater than that, so this is the right answer. So x equal to rounded 0.7408 is. The third third one. Okay, so we have, very good, ln 10 minus 3x, ln negative 4x. So we have both ln on both sides, 1 log, 1 log. I can cancel, but before I cancel, I have to look for the domain first because I have to check answer at the end. So domain is 10 minus 3x is greater than 0. And negative 4x has to be greater than 0. So that means x has to be less than 0. Divided by negative 4, you have to switch, right? This would be negative 3x is greater than negative 10. Divided by negative 3, divided by negative 3, x has to be less than 10 over 3. So this is an and. So at the same time, x has to be less than 0 or less than 10 over 3. Which one is more straight? Less than 0. Is it? Less than 0 is straighter, so has to be less than 0. But now our equation is what? ln I can cancel now. 10 minus 3x equal to negative 4x. Add 4x on, add 3x on both sides. Negative x is equal to 10. X is equal to negative 10. So is negative 10 less than 10 over 3? Well, it is less than 10 over 3. It's also less than 0. So it is the correct solution. This is not an extraneous solution. The fourth one. So first of all, look at the domain. The domain has to be x squared is greater than 0. That means x has to be greater than 0. Can I have x equal to less than 0? Yeah, because actually x can be positive or negative, right? There's no restriction, so just cannot be 0. It can be negative, it can be positive, right? So now, because if you have a negative, you square it, it's still okay. So now because they're all both log, 1 log, so you say x squared equal to 9. X is equal to plus and minus square root 9 equal to plus and minus square root minus 3. And they have 2. I have 2. And so x equal to 3, x equal to negative 3 because both of them are in the domain. The next one, solve this. So this is trouble because I have a number on this side and there's 2 log. If I have 1 log and 2, then I can say 2 to the 2 equal to this, but I have 2. So I have to use log probably to combine them. It is an add, so that means multiply, right? When you combine them, they become multiplying. So we can multiply them later, but I have 1 log now, so I can rewrite 2 squared equal to x plus 4, x plus 1. Oh, I've also forgot about the domain. The domain would be x plus domain. X plus 4 is greater than 0. Oh, not equal. It's just actually greater than 0. X plus 1 also greater than 0. So x has to be greater than -4. X also has to be greater than -1. Actually, greater than -1 is more strict, right? Greater than -1 should be sufficient. So let's look at that. So this, you FOIL this out, it will be x squared plus 5x plus 4, because it will be 4x and 1x is a 5x equal to 4. 2 squared is 4. Because this is rewriting. Rewrite, okay. Rewrite as 2 to the power 2 equal to the inside. So what do I have? So 4 and 4 cancel, because I do -4, -4. So I have x squared plus 5x equal to 0. Oh, that's good. We can factor it as x plus 5 equal to 0. X is equal to 0 or x equal to -5. Is x equal to -5 greater than -1? No, x is not greater than -1. Is x equal to 0 greater than -1 and greater than -4? Yes, this one is, but not this. This is an extraneous solution. So it is important that you do the domain. The next one. So again, this is also 2 log, but oh, this side is another log. So can I just say log, cancel like this? No, you cannot. You can only cancel 1 log and 1 log. So you have to combine this now. So let's say log base 3 x minus 1. When you combine, add, it become multiply, right? Equal to log base 3, 12. Now you see that there's 1 log and 1 log. Oh, I always forgot about the domain. So domain first. X has to be greater than 0, this part. And also x plus 1 has to be greater than 0. So that means x is greater than -1. If it is greater than 0, it should be fine. So this is more important. So let's see. Let's continue doing. Now we can cancel because it's 1 log, 1 log. So x squared minus x is equal to 12. X squared minus x minus 12 is equal to 0. Factor -12 multiply -1 when you add. So it will be -4 and 3. So I'll factor it as x minus 4, x plus 3 equal to 0. So that means x is equal to 4 and x is equal to -3. Check. Is 4 greater than -1 and greater than 0? Yes. Is -3 is not. So this is not a solution. Only this is the solution. So some book will check answer by putting the number back into it, but I just do the domain. It's just a little faster. So do the domain first, right? X plus 3 is greater than 0. X plus 4 is greater than 0. So x has to be greater than -3. Also, x has to be greater than -4. If you're greater than -3, you should be greater than -4, right? So, but anyway, we will check both. So we will combine this. So we see log on this side and log on this side. This is a 1 log, that's good, but this is not good. We have to combine them by multiplying. So log, oh, there's no base, that means log 10, x plus 3 times x plus 4 equal to 30. So let's go a little faster. X squared plus 7x plus 12 equal to 30. So x squared plus 7x minus 18 equal to 0. Factor x minus 2, x plus 9 equal to 0. So you would have x equal to 2, x equal to -9. But this one is not in the domain, but only x plus 2 is in the domain, and that's the answer.